I'm not sure how long it'll take. And also, I'm going to record this. I don't know that I'll be able to embed it on the web page. That's been acting really funny lately. So what I'm going to do is just put the YouTube channel. I'll check it all tomorrow. Okay. Now,
are we doing how many now?
yes. Now, guys, shh. Hey, listen up. Let's go. In order to find these videos, I think what you're going to have to do is go to my YouTube channel and dig a little. Embedding them in the website is taking longer and longer to the point where I can't get it done in the day. So,
Maybe you have a virus.
No, I think the website's just, I think Weebly's just getting very popular.
Maybe you have a virus.
Maybe you're tuning videos on there already and it's filling up?
Shouldn't be the case. I mean, I should be sharing their server space with every other client. I don't have my own dedicated server at their spot, but
Because you're not cool enough.
I'm not cool enough now. I'm not a Weebly Gold Star VIP business class
Obviously.
member.
Well, you should be.
I should be, darn it, at this point. So today, we've been using the term function a lot. We've been using f of x notation a lot. We haven't spoken too much about what that means. And today we're going to talk about what functions and their inverses mean. Jimmy, run, bye. You're going to my class. I don't care, bye. Alright, now, so we're going to call this what the f of x. Okay?
Wow.
Oh, that's
Did you come up with that on your own?
I did. I'm feeling quite clever this morning.
That's actually a good one.
Here's the deal with a function. I'm going to give you 3 definitions of a function. Okay? And they all mean the same thing, but they're very different. First off, why do we use functions? Why don't we just call it y equals all the time? That goes back to René Descartes and his Cartesian plane. I'm going to quickly tell you what he was thinking about. Mostly he was thinking about his 5-year-old daughter who died of a virus, and he wanted to find out what viruses were and try and end them so that no one had to suffer through that again. Did not succeed, because we still have viruses today, but what he did was he basically invented the scientific method. There was good science before him, there were smart people before him, but there wasn't one well-thought-out way to do experiments. So he wrote a book in 1637 called A Discourse on Reason, and the book had an appendix at the end called La Géométrie, in French, the geometry. And what he was doing was he was taking all the ideas you learned in geometry, which were actually like 4,000 years old, and he was moving them into algebra, which he was sort of inventing and expanding on as he went along. Because of this, he thought about how you should do experiments. He basically invented the scientific method. And he decided that a function should mean, this is exactly what it means, this will be the most confusing definition, which I can't spell, one occurrence of the dependent variable for each occurrence of the independent variable. I'm sure this is the point where you all are going, oh my god, now suddenly it's all so clear. Yes. One occurrence of the dependent variable for each occurrence of the independent variable. The thing to remember is he invented modern graphing basically as a side note to trying to figure out his scientific pursuits. So, you guys in science, have you guys ever talked about dependent and independent variables?
Yeah.
A little bit? When one thing depends on another in an experiment? What is the most common independent variable? Time. No, that's not it. We don't usually measure things in units of what you just said. Be an interesting experiment, but maybe for municipal waste they would do something like that. But we almost always, time is a common example of an independent variable. Yeah, you can. Time is the most common occurrence of an independent variable. And then up here there's what you're measuring. There are other independent variables. But that's the most common one. How weird would it look if we measured time going up the y-axis?
Weird.
Wouldn't that give most of you a headache?
Yeah. Sure.
Yeah, it would make my brain explode. There's no reason why we can't have time go up the y-axis, though. René Descartes wrote it this way in 1637. We've been doing it ever since. We're used to it. We're raised on it. But it's totally arbitrary. We could switch it. I'll get to that in a minute. Yeah? No. Relax. Okay. One occurrence of each of the dependent variable for each occurrence of the independent variable. If I throw a football, okay, and I measure where the football is, it might do something like this. Would I expect to throw a football and have it be here and here simultaneously?
No.
No, that rarely happens, right?
Rarely. Does it ever happen?
If you a quantum physicist might say so, but I'm not going to. No, I've never seen it happen. Yeah, you can draw that. So time. So here's another way to write what a function is. 1y for each x. René Descartes decided that x's would usually be the independent variable and y's would usually be the dependent variable. So one occurrence of the dependent variable, where's the football, for each occurrence of the independent variable, how many seconds has it been in the air, means 1y for each x. And then the part you might have heard before is what we call, here's the third way I'm going to talk about what a function is, the vertical line test. You guys ever heard of that?
Yeah.
Okay. The vertical line test says if I have a function, whether that function is a continuous line or a bunch of little dots, depending on whether I'm measuring something with data or graphing an equation, if I were to run a vertical line through the function, okay, then the line will only hit the function at one point. Here's where it would fail. If I have a data point down here and a data point up here, then I have a function fail right there because it cannot hit at 2 points. That is like throwing a football and having it be in 2 places at once 5 seconds later.
Wait, you can't
Did
hit
you
that
really
point?
write ale?
Yes. Using the F from function is the F in fail. I'm feeling quite clever today. Can't you tell? Everything you've graphed so far has been a function. That's why up to this point it's been okay to just say y, f of x, same thing, whatever, don't worry about it. Okay? We're going to start, I don't know if we're going to start graphing some non-functions or not. We're going to look at a couple of non-functions. Okay?
As in we don't graph them?
You'll see what I mean in a minute. Mostly not. Okay, Eliza, you want to follow me over here for a sec? Sorry, Sarah. Okay. Let's see. Example of a function. Very common one. Y equals x squared.
Wait, could you put this in your calculator?
Here's a good point. Nimi, when you hit the y equals button, I just got to answer the question. When you hit the y equals button on your calculator, you see a bunch of y equals, right?
Yeah.
And all you can put on the other side are x's.
Sure.
That's another definition of a function. Not really a definition, sort of a symptom of a function. If you write y equals and all you have over here are x's, then that automatically means you're talking about a function.
So
What
you
is it,
could put
doctor?
it on.
I think you've got a function.
Exactly, yes. But if you can't